Hello guys, and welcome to another Pygame video. In this video I want to do something a little bit different. So instead of being a tutorial video, which will be as well, but this is gonna be slightly different than my other videos. I gave myself a little coding challenge. So I want to code the Conway's Game of Life, and I don't have the code for it. Unlikely for my other videos, for my other tutorial videos, I always have a code that I can refer to. So I code the game in advance and I know how it works, and then I record the video and I have the codes so I can refer to if I get stuck or if I don't remember something. Okay, so it doesn't take too long basically. But for this time I want to do live, so you guys can see how is my thought process to create this code for the games that I've been uploading for this channel. Okay, so we're gonna be coding the Conway's Game of Life. I'm gonna quickly explain that for you that doesn't know what it is. So this is basically a grid. Okay, so the Conway's Game of Life is a cellular automation that is played on a 2D square grid. So we have the grid here. Okay, each cell or each square or cell on the grid can be either alive or dead. Okay, so this, let me show you here, these cells here, you see they can be either alive or dead. So if they're black, that means they are alive. If they're white or the background color, that means they're dead. Okay, and you can actually draw in here your patterns. You can drag the mouse and do whatever you want in here. Okay, and they evolve according to the following rules. So you have a few rules in here that the game checks for it, and then every generation that passes, something happens to those cells. Okay, so the initial configuration of the cell can be created by human, but all generations thereafter are completely determined by the above rules, so by these rules here. The goal of the game is to find patterns that involve interesting ways, something that people have been doing for over 50 years. Okay, so let's quickly go through all of this. So any live cell with fewer than 2 neighbors dies. Okay, so if there is a live cell in here, the neighbors means any square that is surrounds that square in the middle. So a cell can have up to 8 neighbors. Okay, so any cell with fewer than 2 neighbors any live cell with fewer than 2 live neighbors dies. And the second one goes with it as well, because it's any live cell with more than 3 live neighbors dies. So if the cell has less than 2 or more than 3, this cell is gonna die in the next generation. So for example, if there's just 1 neighbor in here, in the next generation this cell here is gonna die. And also in the next generation this cell here is gonna die because there's no neighbors around. Or if there is more than 3, so there's 4 neighbors there. Okay, so there's 3 on the top, 1 here. The next generation, this one in the middle here is going to die because of the second condition here. Okay, the next condition is any live cell with 2 or 3 live neighbor lives unchanged to the next generation. So if the cell has exactly 2 or 3 neighbors touching it, this cell here will live to the next generation. So the next generation, this cell here is gonna keep living. Okay, so if there's 2 in there, it will live, or if there's 3, it will live. If there's 4, the next generation, this cell is gonna die. Okay, and the last condition here is any dead cell with exactly 3 live neighbors comes to life. Okay, so if there is 3 neighbors in here, so these 2 cells here on the top and the bottom, they are dead. So the next generation, there are exactly 3 live neighbors touching them. So this cell is gonna come to life. Okay, and then these 2 cells here, they are gonna die on the same generation. Okay, so this is how it works. I hope that makes sense. Let's just do a quick demonstration here to see how it works. So basically you can, I'm just gonna zoom out a bit, you can just drag, you can do your own patterns in here, or you have some patterns in here that you can choose from. Let me show you this one first here, and then we can do one of the patterns that is in there. I'm just gonna put quite a bit in here so it takes a little bit of time to stop. There you go. And then once you press play, then it starts checking for all those conditions for each of the cells, and then this starts happening. Okay, whoops, I didn't mean to do that. I wanted to move around. So did you see? Okay, and then you can find some interesting patterns like this oscillators here. You see, they just go back and forth, they never change. This square here, it will never change from this position. This or this as well will never change from that position unless something else comes moving around and take them away. Look, oh, it's going all the way down here. You see this one is moving. That's something interesting here. It's going up. Oh, this one went all the way down, the spaceship. Look at those spaceship flying. Okay, I'm saying these names now because the spaceship, the oscillator, and the stationary here is, if you go to the Wikipedia of the Conway's Game of Life, you have some of the patterns in here that you can see. So they still life, so that's the block that we saw there. The beehive, we also saw this one here somewhere. Oh, I think this one is a beehive, you see. And we have some oscillators as well. See, these ones, they keep looping, they keep changing. And then the spaceships is the gliders, so like the ones that just move around in the screen. Like that one there is just moving, that one, okay? And there are some interesting patterns that you can put in there. So there's a pattern in here when you press play, and it shows that. This one is called the Gosper glider gun. So basically it's like a little gun, it keeps shooting spaceships, so you can increase the speed. See, it's very cool. So it keeps shooting and you never leave this pattern basically. Okay, let's stop talking and let's start coding then. What I want to do first is, let me just move this away. Okay, so let's start coding. I went ahead already and I create myself a folder in here on my YouTube folder. It's called Game of Life, and I created 3 files inside of it. So the main, a settings, and a sprites file. They are all empty apart from the settings. The only thing I've done in the settings file is just to add some colors in there. I basically just copied from one of my other codes, so I just took the settings in there, some of the colors, and I just pasted in here. The other 2 files, they are empty because I want to code everything from scratch, as I said. And yeah, if you have seen any of my other tutorial videos, that's usually how I do it. I usually have 3 files. One is the main, one is settings for any of the settings and constants that we want to have on the game, and the other one is where I have all the classes, all the sprites that we're going to be using in the game. Okay, so yeah, if you want, you can just pause the video here. You can just copy those colors. We're just going to be using white, black. I don't even know if we're going to be using black actually. I just put in there just in case because I want to use dark gray. So we're going to be using dark gray, light gray, maybe. And I just set the background color constant to that dark gray color. Okay. So what I'm thinking here, we're gonna first need a grid, right? So to have a grid, I'm gonna have a tile size constant in here. I'm gonna put this constant to 50. I don't know, it might be a bit too big, but we can change after. And we also need a width and a height in here. Let's just use 500 and 500 just for now. It's probably gonna change after. And FPS, I'm just gonna put 60 as I usually use 60. And we want a title as well, which is gonna be the Game of Life. Okay, I think that's all for now for the settings. I'm just gonna drag it, leave it on the side in here. If you guys wanna pause it, you can just copy this now. I'll just leave it in there for now. Now, back to the main file. In the main file here, I want to first import Pygame, and then from settings import all, and then from sprites import all. Okay, so I'm just importing everything from the settings file and then everything from the sprites file, which has nothing there yet. And then in here we're going to first create a class called game. We're going to define a constructor, and first we're gonna initialize Pygame, and then we're gonna have a self.screen variable, which is gonna be pygame.display.setMode, and we give it a tuple with the width and the height inside of it, right? And then we can display the title as well, display set caption actually, and we'll give it the title inside. And we're gonna create a clock, pygame dot is it time dot clock, not tick. And I think that's all for the initializer here for the constructor. Let's define a few functions in here. I want a function called run, which is gonna be self.playing equals to true, while self.playing we want to call the events function, and then we want to call the update function, and then we want to call the draw function. Okay. Oh, and also we need the self.clock.tick in here with the FPS inside. Okay, so this is basically going to be my game loop. Okay, so we get the input from the user, so the events function. We're going to create all of these three functions down here in a second. We get the inputs, and then we update the game if it needs to be updated, and then we render anything that we want to render in the screen, want to draw. Okay, so let's just make all of these functions. I'm just gonna make the update first, and we're gonna make the draw second class, and then the event is just gonna be the last one in here. We're just gonna create this event function as well. We need a for loop in there, so for event in pygame.event.get. Is that it? I think so. And if event.type equals to pygame.quit, then we want to do pygame.quit and then quits Python. Okay, so we quit Pygame and then we quit Python after. Okay, let's test this out. So I'm just going to create an object of game in here and then call the run function. Okay, if I run this, let's see what happens, and we get a window. Okay, so it's a black window. 500 by 500 is very small. This is probably going to change. I'm actually thinking about creating some constant for the rows and columns, so how many rows and columns our grid is going to have, and that will be the size of the window, so you can just easily change the amount of rows and columns, and that will change the window as well. Okay, so the next thing to do in here is to create a grid. As this is like a grid game, I'm gonna create just a function here. I feel like I'm gonna be moving this grid function after, so I'm just gonna call draw grid for now, because I want to create like a class that handles all the grid stuff, like all the board stuff basically. So like to check all the cell and then to check the neighbors of each cell. I want to create a class just to handle all of that. So I'm just gonna create this draw grid here now, just so we can test it, so we can see how it works the game. Okay, so this grid function, we want to have a for loop. So we're going to do for row in range of 0 width and tile size. I've done this way too many times, the grids thing, so I kind of know how it works a bit better now. We're going to call pygame.draw.line. We're passing a screen, a color, and here it takes two tuples. For the coordinates. The first coordinates, it's like the first coordinate of this line, the second coordinate, and it draws a line between those 2 points. Okay, so we have x and y, and then it draws a line between those 2 points. So we're going for row in range, so we're going from 0 all the way to the width, so all the way to 500, but we're skipping by 50, by tile size. So every 50 pixels, we want to draw a line. Okay, so that's what this is doing. So the first command in here, the x, we want it to be row, and then this side as well, the x needs to be row, and then the y, it needs to be 0, which is on the top, and then this one needs to be the height. Okay, so it goes all the way down. Actually, if you're thinking about it, these are the actual columns. So we're actually drawing the columns because it's from the left of the screen to the right of the screen. So all the lines that goes from the top to bottom, okay, from the left to the right. So these are actually the columns. So these are the variables in there. Every 50 pixels, okay, we're gonna be drawing this x coordinate. Just gonna skip by 50, and then we draw from 0 to the height. And then for the other line, so let me just show you what I mean here. Let's just create this function here, the draw function. We will need to call the draw grid, but before we do that, we want to fill this screen, yeah, with the background color, and then after that we want to call pygame.display.flip. So we flip the display. So if I run this, let's see what we get. I use dark gray in here. I don't want dark gray, I want light gray. Yeah, there we go. You see? So we're creating all the columns basically. That's why I changed this to column. So the variable is the x. You always change the x going from the left to the right, and then we're creating the y. It's like from 0 to height. Okay, this is a bit too big. I'm gonna actually just decrease this. I'm gonna put 20 for now. Let's see how it looks. That looks a little bit better. Let's just do the rows now as well. So the row is going to be very similar, so that's why I just copy and paste. It's going to go from 0 to the height in this time, and we're still going to skip by tile size. We want to draw a line at the screen, light gray, and this is going to be the opposite. So it's 0 in the x, and then row for the y, and then width, and then row. Okay, so I run this. There we go. I get this grid in here. Let's do the rows and columns that I mentioned before. So in here, let's just go, we're just gonna go at the bottom here. So we're gonna create a variable for rows and one for columns. The rows is gonna be, well, actually these ones, they're gonna need to be before the width and the height. So let's just put them in here. Rows, let's just put it 100 and 100 for now. The width, now it's what's gonna change. So we want to have rows times tile size, and then for the column, the same thing, columns times tile size. Okay, so let's just see when I run this. Oh, okay, yeah, this is huge. Let's just decrease this. Let's put 50 and 50. Let's see what happens. Okay, that's a little bit better. Okay, I think it's still a little bit big, but let's leave it at 20, the tile size for now, and then we can change after. Just one more thing, you see that you can't really see the last line here on this side of the window, and the one on the bottom, you don't really see the line. Okay, to fix that, you can just literally add 1 to the rows, to the width and the height. Okay, so plus 1, and we run it. You see now we can see. So I just added 1 pixel more to the screen, to the right and down. So now we can see it looks, I think it looks a little bit better because you can see the one on the left and on the top. Okay, so the next thing to do in here, I'm thinking, is just to start creating the sprites. So just to create the cell class, which is gonna be each individual square in here is gonna be a cell, and then we're gonna be able to click on them and make them alive or dead. And then once we, maybe I'm thinking we can press like the space bar or the enter key or something, and then you start the generations. Okay, so let's do that then. Let's go in here into the sprites file. We want to first import Pygame, and then from settings we want to import not like that import all, and let's create a class called a cell. We want to define the constructor. This constructor will take an x and y. I think that's what we need right now. So the position of the cell. Let's do self.y, self.x, self.y is equals to x and y. And just another variable that we might need in here is a variable to see if the cell is alive or dead. Okay, so that is gonna start as false, I guess. So all the cells are going to start default is going to be false. Now to draw this, what we want to draw is, we only want to draw if the cell is alive. Okay, so if the cell is dead, then we don't need to draw because it's going to be the same color as the background. So let's just define this function draw. We should take this screen there because we're going to be calling this on the main game. And if self.alive, then we want to draw a square. So draw, pygame.draw .rect, take this screen. The color, we're gonna be using white when it's alive, and then when you're drawing a rect, it takes just one tuple containing the coordinates of your square, so the top left coordinate of your square, and then the size, the width and the height of your square. So the coordinate is gonna be self.x, self.y, and the size is gonna be tile size by tile size because it's square. So we only draw this white square if the cell is alive. If it's not, it will not draw. So that means the cell is dead. Right. What am I thinking here for the next thing? I think I'm gonna create this, like this grid class that I was talking about, or the board class. I don't really know what to call that. We have a class called, let's call it grid. We'll have a constructor. I don't think we don't need anything on that constructor because that's gonna handle, it's gonna be the entire screen. And let's just pass this for now. What do we want in here? So basically we want to have this draw grid inside of that grid class. Oops, there we go. I'm just gonna copy that in here. Instead of giving this self.screen, we need to just take this self out and then we pass this screen from here. Okay, and then just to test it, this is working as it should. We can come up here, we can create a grid object from the grid, and then we can call self.grid .grid, and we just need to pass in this self.screen side. If I run it, okay, should be fine, still drawing the grid. Okay, because we need to handle so the event as well. Whenever we click on a square, you need to create the, okay, so what I'm thinking, the next thing is to create a cells list, which will hold, it's going to be like a 2D list, I assume, which will hold each of the cells, okay, for this grid. So whenever we start the game, we're gonna initialize all of the cells as dead. Okay, we'll see if it's gonna work or not, because it's gonna be a lot of creation, a lot of objects, a lot of instantiation here of the cell. If it's a bit too slow, then we can try to come up with a different way. If not, then we can do like that. We can also do it every time we click on a square. We can also initialize the cell and initialize it as alive as well. I don't know. Let's do it this way first, and if it's too slow, then we can try to come up with a different way. So what I'm thinking is we're gonna create a cell list in here, and we're just gonna create like a for loop to fill up all of the grids, each of these squares here with a different cell. Okay, so with a different cell object. So let's do a self.cell, which is the list, and we want to do a for loop. It's going to be a double for loop because it needs to be a 2D list, right? So let's do for x in range. We want to go again from 0 to the width, skipping by tile size. So these two for loops in here, let me just show you what I mean. Oops. So we're gonna have two for loops in here, right? And then the second one is gonna be height by tile size. These are gonna be, and then we're gonna be instantiating a cell object in here. And these x and y, they are gonna be the coordinates that we're gonna be giving on this cell in here. Okay, so that's gonna be the coordinates. So we want the cell, this square here, to be drawn every 50 pixels, so every tile size to the right and every tile size down as well. So that's why we're doing the same way as here actually. Okay. But instead of just doing like that, what I want to do is I want to create a row variable here, temporary variable, which is a list, and then we're gonna actually append to that row a cell containing the x and y, and after the second for loop we want to append this row to the cell. So this way we create a 2D list containing all the cells in the grid. Okay. Okay, so just to test this, how can I test this? I just want to actually put this in its own function for now. So let's just create a function called create cells, I guess. And we'll just call this self.create cells in here. To test this, I want to just go through this. So for row in self.cell and for cell in row. So I'm just doing a for loop in here to go through every row in the cell and then every object in that row. So each cell in that row. Then I just want to do cell.draw. Right now we're not going to see anything because all the cells are dead, but let's see if I change this to true and I initialize it. Now they are all white on my face. Now they are all white because they are all alive. Okay, and it actually didn't take that long to create and to instantiate, so we're just going to leave it like that. Okay, so let's just change this back to false, and let's create this event in here to handle the mouse inputs. So we are able to just click and initialize a cell. Okay, so to change a cell from dead to alive. Okay, so let's check for the mouse event. So if event.type equals pygame dot mouse button down, we want to say mx my equals to pygame dot mouse dot get position. So this function here returns the position coordinate in a tuple of the mouse where the mouse is on the screen, and we're just saving them into two separate variables, the mx and my. And we want to so now we need to check if we're actually clicking on a cell right? I think for that we're gonna, let's just go back to the sprites here. In our cell class, we want to create a function here, define is clicked, okay, and we're gonna give that mx and my. So we're gonna be calling this function for each cell in here and giving the coordinate and seeing if we're clicking on a cell. So which, depending on the cell we click, if we're clicking on this specific cell, then we're going to be changing that alive variable, right? So in here we just want to return self.x less or equals to mx less or equals to, oh sorry, just less, not less or equals, self.x, I'll explain that in a second, plus tile size, and self.y less or equals to my less than self.y plus tile size. Okay, so we have x, mx, and my. Right, so this is basically, we're just checking if the x coordinate of the mouse is between the left and the right side of our cell, and here is checking if the y coordinate is between the top and the bottom of our cell. Okay, so I put equals on this side and not on this side. That means if we manage to click on the line on the left side line of the cell, it will still select the cell, but if we click on the right line, it will not select. Okay, if I put equals on both sides, that could be a chance of you clicking on the line and then selecting two cells at the same time, so the left and the right cell. So that's why I did like that. You can do like that, or you can do it like that as well. If you don't put any equal sign, it could happen of you clicking on the line and then it's not going to select any cell. Okay, so that's why I just done it like this. Let's go back in here. We want to just do that loop again. So for row in, it's going to be self.grid.cell. Is it just called cell? I want to call this cells actually. And cells, self.cells, and cells. Okay, and then for cell in row, we want to check whether the cell is clicked and give it the mx and the y. So this is going to return either true or false. We can use the if statement here. So if that's true, then we just do cell.alive equals to true. Actually, no, we're going to do not cell.alive, because then if the cell is dead, if this is false and we click on it, then it's going to become not false, so it's going to become true. But then if the cell is true and I click on it, I want to make it dead, right? So then it's going to become not true, which is false. Hope that makes sense. Okay, let's run this and see how it behaves. I did something here because I changed the name of the cell. Now here I need to change it as well. Alright, so there we go. So if I click on a square on a grid, I can draw this point. Okay, I cannot drag and draw yet. I don't think I'm going to be implementing that. It's not really necessary in here. I think I'm gonna do like something randomize at the end. But yeah, so we have the functionality. If we click on another cell again, we can make it dead, right? Okay, so this is working fine. I think the next thing to work on is probably to start the generation and then do all those checks. Let me see. So we want to use the space bar. Okay, so if event.type equals to pygame dot key down, and if the events.key is equals to pygame.k underscore space, we want to start the game. Okay, so let's create a variable in here, self dot start game equals to false, and then if we press the space bar, we want to do self dot start game equals to, let's use the same principle in there, not self dot start game, because then if you press space again, then you can kind of pause the game and then draw again if you wanted to. Okay, right, what is the next thing to do in here? I've done this. Now I guess we need to start coding the actual, all those checks basically. So I'm just gonna go back in here into the Conway's game of life thing, because I just want to copy, I just want to copy this. That didn't work. Why did it come like that? Well, I don't know. I just want to copy this thing in here. Okay, now we just comment all of this. Okay, I just want to copy all of this condition so we can have in here, so we can refer to it if we need to. Right, let me see. I think we're gonna have in this grid class, we want to probably have a function to check the neighbors, right? So what I'm thinking is we want to loop through the grids and then check for each neighbor, for each cell, okay? And then, for example, we're gonna go through it, all of that, and we have all these checks. So let's do for this one, we get to this cell here, and then we're gonna probably have like a counter to see how many live neighbors we have around this, and then decide after what we want to do, if we want to keep living the cell or if we want to turn that alive variable to false. So we're gonna check this neighbor in here, that's dead. We're gonna check this neighbor, this dead, this one. Okay, so there's a neighbor in here. This neighbor is alive, so we add to the counter. This neighbor is alive, we add to the counter. This neighbor is dead, we don't add. This neighbor is dead, we don't add. So our counter has 2 live neighbors. Okay, let's see what we do with that. Any live cell with fewer than 2, any live cell with more than 3, any live cell with 2 or 3 live neighbors live. So okay, this middle cell in here is gonna keep living for the next generation, so we don't change it. And then we go to the next cell in here. We do the same thing, we check all the neighbors. This cell in here, in this case, has only 1 live neighbor. Okay, so what that means, this first one here, if it has fewer than 2. So this cell in the next generation is going to die. So we change that alive variable to false. And we're gonna do that for all of them. That's what I'm thinking. Maybe not as efficient, maybe very slow, maybe, don't know, we'll see. But let's just try like that and see how it works. So let's do neighbor, and also I'm thinking about like this of checking all the cells around is because I've coded a minesweeper. I actually recorded already. It's probably gonna come out after this video or maybe before, I don't know. And the minesweeper, if you don't know, you have a cell in the middle, so it's very similar to this. Let me just show you that. Wait. We have like a cell in the middle, and we need to get the clue for this cell, so numbers between 1 to 8, depending on how many mines we have around this cell. Okay, so it's the same thing. So we take this cell and then we check all the neighbors around. If any of them are mine, so if this is a mine, we add to a counter. If this is a mine, we add to a counter. So there's 2. Then this clue here is the number 2. So that's why I'm thinking like that, because I'm gonna use kind of the same principle to check the neighbors around. Okay. Okay, so let's just continue this. Let's do actually check neighbors. Brackets in there, And as I said, we need a variable in here, so live neighbors equals to 0 first, and we want to do a double for loop. Actually, we're gonna need to pass in a cell in here, because I think on the update function in here, on the updates part of the game, we're gonna loop through the boards or the grid. We're gonna take each cell and then we call this check neighbor, and then for each cell we're gonna check all the neighbors around it, right? So we're gonna have to give this cell in here. So for x in range of -1, we go up to 1, so it's gonna be 2. Okay, this is gonna be the x offset basically, and then we're gonna do the same thing for the y offset. Okay, so we're gonna take a cell coordinate, okay, so a grid coordinate from this list in here, and we want to check one row above and one column before to be able to check this neighbor here. So that is -1 compared to this one in the indexes, I mean, yeah, -1 compared to this one, and -1 compared to that one to the left. Then we want to check this neighbor here, that is -1 compared to this, and then 0 on the x compared to this one. This one will be +1 to the right, and then +1, and then sorry, this is going to be +1 to the right and then -1 up. This one is the same. It's 0 and then -1. Okay, and then for this one it's going to be 0 on this direction and then -1 to the left, and so on. Okay, so that's why we go -1, 0, and 1. This is the offset. We're going to be adding that to our cell coordinate. Okay, so that is exactly how I've done it for the Minesweeper in here. I can actually even show you. Where is that? Is exactly this what we're going to be doing. Okay, so we have that offset, and then we're gonna take the neighbor x and y, which is the offset plus the actual x coordinate of the neighbor. In this case I gave it an x and y in there, and that's how we're gonna be doing. And then actually we're gonna need this function in here. I'm just gonna copy this function from here as I'm here already. Gonna copy that, paste in here. This is just a static method, you don't really need that in there. Self, and then let's just take an x and y. So what this is inside function is doing is just checking whether the x coordinate and y coordinate that we're going to be giving, so these values in here, or not this, but the neighbor coordinate, if it's inside of the grid. Okay, because if we're actually checking this cell, for example, we cannot check this one here. It's going to give us an index error if we try to check that one there. That's why we want to just check if it's inside. And the rest is going to be very similar to this function here, but let's try to code that. So we have the for loop in here. In this for loop, I want to actually do the x neighbor. It's gonna be equals to, okay, so the cell.x is actually a pixel coordinate, right? So we're gonna have to actually divide that by tile size to be able to find this specific cell coordinates in this list. Okay, so we just integer divided by tile size, because now it's a pixel size. Okay, so it's gonna be like 200, for example, and then 200 in pixel size is gonna be, or actually that's 0, 20, 40. Let's say it's 40 on the x in pixel size. If we divided that by 20, then we're gonna get 2, which is the index. Okay, so that's what we want. We want the index in here, we don't want the pixel coordinate. And so we need to divide that, and we need to add that x offset in here. Okay, and then we just do the same thing for the y. Okay, now we look through it, we're gonna check all around. So the first thing we want to check is if this coordinates x neighbor and y neighbor is actually inside of the board. Okay, so if it's not, then we cannot check, because otherwise it's gonna give us an error. And what else do we need to check in here? We don't want to check we don't want to check the cell that we're in. Okay, so if x not equals to 0 and y not equals to 0, okay, so 0, 0 is the cell that we are actually in. So we are checking this cell here, we're checking all around this cell. We don't want to check this actual cell that we're in right now. Okay, so we don't want to add that to the counter, we only want to check around. So this is -1 and -1, this is 0 and -1, -1 and +1. So it goes on -1 and 0. So this one here that we're actually in is 0, 0. Okay, and this for loop in here. So if x is not equals to 0 and y is not equals to 0, then we want to, what else do we need to do in here? And then now we want to also check if self.cells at this coordinate neighbor dot alive. Okay, so now we're checking if that cell is alive. Then if it is, we want to add that to the counter. But let me do this a little bit different, just to make it a bit nicer. I'm going to put that in there, and I'm going to put this one in here. Okay, can actually even put, let's leave this one there in for now. So if it's not 0 and 0, wait, this is not gonna work, is it? If x not equals to 0 and y not equals to 0, but then if one of them is equals to 0, then it's not going to go inside. Let's try first, and if we get some bugs, then we can come here. I'm pretty sure that this is not right. We're going to have to do a bit different, because we have two conditions in here. We want to check for one condition, right? But if I do that, that's redundant. Okay, let me just continue with this in here. And here we want to do live neighbors plus equals 1. So we want to loop through all of this. We take the x and y coordinate of the neighbor that we're checking. If they are not 0, so the current cell that we're in, we check if it's actually inside of the board, and that neighbor is alive. We add to the live neighbor count. Now we need to do these checks. Okay, so now it's where we do this bit in here. So we're gonna do that for each cell. Okay, so we do that, then we have the live neighbors count. Any live cell with fewer than 2 live neighbor dies. It's unpopulated, so if cell dot alive and live neighbors less than 2, it's gonna die. If cell, so the second condition here, more than 3 live neighbors, cell.alive and live neighbors greater than 3 will die. Okay, overpopulation. Any cell with 2 or 3 live neighbor lives. So if cell.alive and live neighbors with 2 or 3, so if how do we do this, like that, I guess, equals and then less or equals to 3, right? So between 2 and 3, including 2 and 3. So this is the 2 or 3, then this one it will leave. And the last one is if cell dots, so if not cell dot alive, so if the cell is dead and with exactly 3 live neighbor and live neighbors equals to 3, then that cell will leave. Okay, so that's the last one here. Okay, so let's try to combine all of this a bit more, right? So what I'm thinking is I want to just put this on the top because it's the only one that is not alive. And 3, I don't know if there's anything else I can do in there, so this one is gonna be cell.alive equals to true. So the cell was dead. It has 3 neighbors, become alive. Now here we want the cell is alive and we want less than 2 and oops, maybe like that. Well, it can't be less than 2 and greater than 3 at the same time, right? How can I put this? If less than 2, let's just leave it like that for now. How can I less than 2? So we want to less than 2 and greater than 3. I guess we can negate this, right? We can actually do this. So between 2 and 3, but then if we do not between 2 and 3, right? So we just negate this. So if the live neighbors is between 2 and 3, this is gonna be true and not gonna be false. So if it's not between 2 and 3, this is gonna be false, and then they're not gonna make it true. The cell will die. So that was those 2 conditions in there. And then this last condition here, if the cell is alive and there is the live neighbors between 2 and 3, actually we don't need this condition in there, because if the cell is not alive and it has 3 neighbors, then it becomes true. If it has less than 2 or more than 3, it will die. But then the other one is between 2 and 3, it will stay alive. So then it will just stay as it is. If it's alive and it's between 2 and 3, and it stays alive. If it's dead and between 2 and 3, it will stay dead, right? Because it needs to be exactly 3 to become alive. So yeah, actually we don't need that last one. I think that's it. So those 4 conditions in here we managed to put into 2 if statements. Hopefully that is correct. We're gonna do some tests in a second here, and then we're gonna see how that's gonna behave. Okay, so let's test this, I guess. How can we test this? In this update function here, in the update function, we want to call that, we want to loop through the cells. So for row in self.grade.cells and for cell in row. And then when we want to call this, that's how we want to do. Because then if we do it like that, we don't need to wait, then we don't need to actually give the cell to the neighbor. Oh no, we need to call self.grid.check neighbors and then give it the cell, right? What if we put this check neighbors? Now I was thinking of putting into the cell class, but that doesn't make too much sense actually, because this should be part of the grid. Yeah, let's just continue like that. So we're just looping through the cell, we're just calling the grid cells, then we're just calling every cell, every object, and then we're just giving that cell inside of this check neighbor here as an argument. Okay, so inside of here we are taking that cell X and Y, the current one, we're finding that neighbor, and then we're doing all the checks, we add to the live neighbor, and then we're doing all of this check in here. Okay, go back to this. So we want to do that. Let me see if I run this. It's because, yeah, I'm not going to be able to add this. We want to do that only if self.startGame is true. Okay, because we want to have some time to place some stuff. So basically I'm just gonna do a couple patterns that I know it would work. Okay, so there's this one here should stay stationary, and then the oscillator should change between those 2 patterns. Okay, so I'll press spacebar and nothing happened. Why? Let's make a generations variable in here, and we want to do self.generations plus equals 1, and then print that self.generations, just to make sure that this is working right. So if I press, yeah, it's moving all the generations. Oh, I know actually what it is. I think it's this thing here. If we try printing here the X and Y, and then I run it, wait, let me remove the generations, and I actually need to add a few cells, press spacebar. Yeah, that's what I guessed. Do you remember that I said that this was not going to work? It's because it's not checking for 0. So we need -1, -1, and then -1, 0, and then -1, 1. So we're not checking for the zeros in here, because we're checking for 2 conditions in here, right? So if X is not 0 and Y not 0. So if either of them is 0, then this whole condition is gonna be false straight away as well, and it's not going to check for this. So I tried putting this, but this is actually redundant because I want to make this thing one condition. So doing like that, it's gonna be the same thing, right? Yeah, it's gonna be the same thing. So we're probably gonna have to invert this. So we're gonna have to say if x equals 0 and y equals 0, and then just put a not in there. I think that's how we're gonna have to do it, because I wanted to make this as one condition. So if x is 0 and y is 0, this is gonna return true, and this is gonna return not true, right? And if x is not 0 and y is not 0, this is gonna return false, and then the not in here is gonna make it true, so we're gonna go in here. Okay, if x is 0 and y is not 0, then this is gonna return false, which is gonna change. It's gonna return true with the not, so it's gonna go inside. So it's only gonna return false if x is 0 and y is 0, because this whole thing is gonna return true, and with the not is gonna become false. So it's not gonna go inside of this if statement. Let's just test this to see if it's working. I'm just gonna do like that, and I press space. Okay, it stays there. Let's try the oscillator. That didn't work. Right, why not? Alright. Well, I don't need to print that anymore. This is actually working with all the zeros in there. That's fine. Is it these conditions here? Is there anything wrong in here? Not cell, less than 3, live. But this one works, right? I'm just gonna print the generation spec in here just to make sure that it's actually doing something. That is working. And then when I do this, it does that. If I do that, it does nothing. I mean, it's doing something. I know this is the beehive. That one is staying. Oh wow. Okay, there's clearly something wrong in there. Oh my. What have I done? Pretty interesting though. Not working as intended, but pretty interesting. Okay, let's try to fix this. Let me just give me a couple of minutes, guys. Let me just do some tests and try to find the mistake in here, okay? Alright, I think I found it. I haven't tested yet, but I think that it's because we are checking the grid and we are updating everything at the same time. We actually don't want to do that, because so this is not working here, because we're checking the grid from top to bottom, from the left to the right. So we go like that, blah blah blah, and we check this one, this one, this one, and then we check there's, for this guy here, there's only one neighbor alive, so we make this guy dead straight away. We don't want that. We want to keep the data that this is gonna be dead on the next generation, but we don't want to kill it straight away, because then when we check this, that's gonna have only one neighbor as well, so that's gonna die, and then this one's gonna have no neighbors, so that's gonna die. So that's why when I do that, it's just disappearing straight away, right? I think. But if we do this, it does that. Why is it doing that? Let's check. So we come in here. This guy here has one neighbor. So it's going like that, right? This guy here has one neighbor. So this guy here will die. It should be the same thing. I don't know why it's going down. Oh, wait, so I need to have exactly 3 neighbors. This one has only one neighbor, that one will die. This one has only one neighbor. This one has 2 neighbors. That will die. This one only have one neighbor, so fewer than 2. This one will die as well. This one should die as well. Why is this becoming a square? I don't know. That is something I'm not sure. But yeah, I believe it's because of that. So we need to save the data that this is going to be dead on the next generation, but not kill it straight away. For that, what I'm thinking is to create another variable in here called self.dead. In this case, it's going to be true. So if alive is false, that means it's dead. So dead is going to be true. And then in here, instead of checking for alive, we want to actually check for this other variable. So I'm just creating another variable in there to keep the data. We could have made another like alive 2 variable and make it to false, but let's just do it alive and dead. I guess it's just easier. This makes sense. It's probably not the most efficient way to do this, but again, this is just for the sake of the time, and it's quite long already. Okay, so if this is not dead, then we update. So this shouldn't change much. And then in here we want to still check for the alive, right? And then yeah, this should not work still. Okay, yeah, it's the same thing, right? Let me just bring up my console back. So what we're gonna do is every time we want to update those cells. Okay, so if the cell is alive, we want to update this dead variable as well, and if it's dead, we want to update the dead variable. So basically, we want to go through all the cells, and then we want to call cell dot. I don't know if I can do in here. If cell dot alive, then cell dot dead equals to false, else cell dot dead equals to true. Don't know if that's gonna do it, because yeah, that's what I thought. So I actually need to update it when I do this as well. When I click on the cell, it needs to update, but it's not updating because it's not inside of the start game. So I will have to actually do this for loop again, but outside of this if start. I don't need to check for the neighbors again. And then when I do that, it should update the cell with this straight away. Okay, so if I click on it, it makes the cell alive. Or what we can do is in here, I can do cell.dead equals not cell.dead actually. So then we don't need to do this again, and we can just keep this one in here. Would that work? Okay, that's promising. Let's try the oscillator. No, didn't work like that. I feel like there's something wrong with there's something wrong with this X and Y. I'm not sure. Let's see. Let's go back in here as I had this before, like this, just to have a proof of concept. This should work in there. So whenever I click it, it should update that as well. Yeah, it's still not working. I don't understand why it's doing that. Oh, there's still something wrong. I don't know if it's something wrong with this thing in here. Let me just have a think. No, here. Do I need to remove this one from here? Let me, if I take this down, so I only have this one here, right? Let me try this. Oh, okay. So it was this. There was something wrong in here. So basically I cannot check the neighbors, the cell, and update. Yeah, of course. That's why we create that self.dead. It's so we don't actually do this. So we need to update, check all the cells, all the neighbors, and then we go through them again and we update them all again. And that is it, my friends. Let me just put it a little bit slower so we can actually see what's happening. Yeah, that is the oscillator in there. This one like that. The beehive is this one, starts like that. Let's check the Wikipedia here, because there's a few things in here that we can do. Like for example, the spaceship, it's like so, right, I think, and that goes down. Look at that, beautiful. Let's see if we start forming some patterns. Ah, now it disappeared. I'm not gonna do those other ones in here because they're very difficult. Okay, so it looks like it's working now. The last thing, just what I wanted to do in here is just to randomize this. So if we press like the return key on the keyboard, let's say, we randomize the cells to be either alive or dead. So I'm gonna create a function here called randomize, and we want to do we want to loop through the cells again, and then for each cell we want to do cell.alive equals to random.choice between 0 and 1. Okay, so 0 means false, 1 means true. So we're just, for each of the cell, we're just randomizing the chance to be either alive or dead. Okay, it's pretty easy, this function. In here, as I said, let's just check for the event.key equals pygame.k_return. And if we press return, we want to call the randomize function. Run it, press return. Yeah, it randomizes every time I press the enter key. Space bar. Nice. All right. Look at that. Now it stopped. Press enter again. Just randomize again. You can stop, press enter, and just see patterns. Let's try to make it, let's push it a bit. I'm gonna put 100 in here and 100. Yeah. It still works. Actually, it's not, I thought it was gonna be much slower for processing. I mean, maybe it's my computer as well, but yeah. Okay, guys. You can also, if you want, you can actually get rid of this grid. Let's see how this looks. Okay, it doesn't look as good. What we can do, yeah, no, actually it doesn't look as good. It's better with the grid. Oops. Alright guys, that's gonna be it for this video. I hope you enjoy it, and thank you so much for watching. Subscribe to the channel if you want to see more content like this. Drop me a like below, drop me a comment if you don't understand something, or if you done this and you found some other bugs or stuff like that. Just let me know. I'll see you guys on the next video. Bye bye.